Meet echo?
No, no, no. It just, I don't know if it's the PA system or if it's just too loud or whatever, but.
This is side meeting. Hey, what is in the other room?
The routing area, there is a meeting. This is the best one?
Okay, folks. Okay, you hear me? This is 5GIP mailing list side meeting, IETF 95 in Buenos Aires. And this is the agenda up there. Since we are not officially chartered or anything, we don't have to do any agenda bashing, but if you have any question on the agenda, the times are, of course, we try to impose, but the one we are going to do, we cannot really that much be strict. Maybe we can exceed a little bit. Okay, if everything is okay. I guess there was a request about the slides. After the meeting, we have all the slides, and hopefully we can post it on the mailing list. I think that is the best way for us because we have no other place. Okay? So don't worry about the slides. Just, listen and watch. And then you're going to have the slides after the meeting. Okay. And the sign-up sheets are circulating around. Please write down your name. Just for us, it's not nothing official. Oh, the other thing is mailing list. I'm sure you guys are all on the mailing list. Make sure if you are not to subscribe or let us know, then we're gonna subscribe you to the mailing list. Okay? Okay. So we start with GM. Is the first. We have a couple of remote participants on the meeting here and see, so we can have some questions from them too. Okay.
Okay.
Oh wait, I have to get your slide. Which one is it? Yours was PDF, right? PDF file.
Yeah, PDF.
Okay. This is the prepared. Yeah, PDF. What was the name?
5G?
This mobile edge cloud? No.
No. 5G.
What was the name?
5G caps.
5G.
No. Caps. Start from caps?
Yes.
No.
No. Not this one. Samples, no.
No.
Vehicle, no. Okay. This one? No.
No.
Let's see, where is this one? Actually, no. Let's go. I thought I
find it.
I need to check the mail. Sorry about that.
No problem.
I thought you sent me to which mail?
Actually,
Oh, here. I thought
Yeah.
I saved it. Sorry. I'm sorry about this thing. Terrible. Right, actually. Yeah. Okay. Sorry for the delay.
Gaps.
Oh, gaps, yeah. Maybe I forgot to save this file. My mistake. I also don't know. Okay. Oh,
Maybe you
My
can
Wi-Fi.
shift the other ones to present first. And
Wi-Fi. Oh, no, no. I have Wi-Fi. Okay. No, it's okay. Should be okay. You should. Okay, wait till you get the other
yeah,
one.
yeah, shift.
Okay, we go to the next presenter. Dirk, sorry about that. I think I have yours. I'll find the other one in the meantime. This one, right? Okay.
Okay. Yeah. Thanks for coming. So this is essentially a summary of a little article I wrote at the end of last year, and then some subsequent discussion we had on a couple of mailing lists. And it's essentially a call that when we think about what we could possibly do in 5G, really take a close look what's actually wrong in today's networks and what can we actually learn from the problems that we're experiencing today. Next slide, please. Can I have the remote?
Yeah.
Yeah, it makes it easier.
Yeah. Good.
Doesn't work?
Network. Nothing is working. Right? Oh, okay.
Okay. So when you say looking into the textbook how mobile network looks like today, so you see things like access network, core network, application servers, user equipment, and so on. And then there are a couple of protocols, mobility management, and so on to make this work. But so in practice, we have a whole lot of machinery that is actually needed to provide useful service today. Next slide, please. For example, can you move on?
Next. Okay.
For example, in a say, typical network deployment, you would see at least one TCP proxy, if not more, which is really deemed necessary by operators like to have better control of congestion control loops. Next slide. There's quite some elaborate machinery for traffic management, so extracting real-time information from base stations, so radio data, and then using that for policing, for example, or other forms of traffic control. Next slide. There are definitely there are a bunch of application optimizers, so video optimizers mainly, that do things like transcoding. Next slide. Keep going. And so in the IETF, people also have thought about say how to directly inform application servers better of what's going on in the network. So there's a proposal called mobile throughput guidance. So you get a bit of the idea. So there is lots of stuff that is needed in practice to provide good performance today. And can I somehow advance myself?
Oh,
okay. Yeah. So in addition of that, to that, and as you know, you cannot really roll out a major service today without CDN. So that's another, say, essential component that also needs to be considered when you talk about the big picture. So CDN today is mostly done by like having big caches at co-location points and so on. But in the future, there are definitely trends to move this deeper down into the network. So edge caching, these kind of things. And this is essentially needed if you think about like the upcoming applications. So blending video on demand and linear TV, having a multicast-like distribution tree with that. That's another thing that we are adding on top in those networks. And if you think about other applications, so there's not only like the Netflix cache, there's Akamai, there are social networks. There's a danger also that we are really arriving at a slightly complicated and also siloed system in the end. So a couple of observations. So today already we need a significant amount of stuff to really make things just work. And so it has not only to do with TCP and performance, but then that's one of the topics I wanted to allude here today. So caching is really important, and this is likely going to increase. Question is, so if you want to enable new use cases, so new so-called OTT applications, what will that actually mean for a, say, useful and manageable network in the future? And so what does it mean for 5G? So if you look into the, say, published NGMN use cases for 5G, there are a couple of things that are interesting. And if you try to distill the technical requirements for that, so I only picked like two here. So if you want to cover IoT, sensor networks, tactile internet, so super low latency internet, you have to really think about what you can do for performance, so optimized forwarding for all these different kinds of access technologies in one system. If you like move more and more critical service to the network, you have to really think about security and user privacy. I mean, that's a topic we are thinking about hard today. And for security, so I mean, I think it's safe to say that HTTP2 it's here to stay, and it's good because we want to have more encryption in the network. And on the other hand, it also creates quite some headaches. So for operators that have been used to use all this machinery, like traffic management, application layer optimizations, and so on, to provide better performance, so this all becomes more difficult now, at least, or more expensive. And so we will have to think about other mechanisms to do that. So we are partly doing this. So there's an Accord BOF this week that is tackling some of these things. But it's not trivial. Another thing regarding security is, so when we say TLS, it's often like sold as providing better user privacy because your connections are encrypted. In fact, what it means that normally that your connection to the next CDN cache is encrypted, and what happens after that is actually beyond your control. So of course you can assume, so Akamai probably will encrypt the next hop as well. But what happens to your data in the cloud? So this is, of course, by no means protected. And so our TLS, so channel-based encryption service today, protects the connection, but not really the user data, so that we have no control, no ways to authorize copying or spoofing and so on. I may need 6 minutes. I may need 6 minutes. So, and the other topic is, so if you want to address all these, say, demanding use cases, it would probably be difficult to implement this with like TCP as is today. So these different control loop conservations, it's not really an attractive solution to extend the use of TCP proxies. So I think that that's a road nobody wants to go down. So network of proxies doesn't really sound convincing. So what I want to do propose, and I kind of explain it a bit more detail in my article, is to think about more, say, additional forwarding layer functions that could help in covering all these heterogeneous network links. So, for example, enabling local region transmission in some cases, enabling a simple form of caching without requiring the full CDN complexity. So that's like one idea in the space. And
That's it.
okay. Okay. So I got I think really interesting feedback on this that is also on this slide. But so if we have time later, maybe we can go back to this.
Yeah,
Okay.
yeah. Okay, thank you. Dirk, any questions on that? Quickly, one question.
Hello, Kevin Smith, Vodafone. So my take on this is that really the major problem is the lack of harmony between the radio layers and TCP flow and congestion controls. And if we can get that right together, we probably won't need the TCP proxies at all.
Yeah, hopefully. I mean, okay. So so one of the things that is probably true is there's lots of say AQM technology that is not really deployed right now, so that could be helpful to improve end-to-end performance for TCP. It was also one of the comments I got from people.
Thank you.
Hi, my name is Padma Snow. I have a question specifically about the hop-by-hop forwarding that you mentioned.
Right.
The reason why is because I really think that for QoS and eventually optimized routing, how do you expect this to work with hop-by-hop? I think there should be other mechanisms on top of that, right?
Right. I mean, this is certainly a like future-oriented proposal. So, but there is work, for example, in the ICN community on like flow balance and so yeah, hop-by-hop congestion control. So the idea is basically that you enable the forwarding layer, or you provide better visibility for the forwarding layer. For what's going on in the network regarding latency to your next hop, for example. So this can be done if you have a bit more visibility of, so in ICN, the kind of request names, for example, and match that to your different outgoing faces. And so that you can achieve better performance. Of course, it's not something that you can do directly today without modifying the network. On the other hand, I mean, so we talk a lot about slicing in 5G and software-defined networks and so on. So it's not that these things are totally impossible or say really expensive to implement. So you can experiment with these things today, and so people are building software routers for 5G right now.
Yes, one thing in particular that I have in mind is about session continuity. I don't see how we can do that with hop-by-hop, especially with a latency of sub-millisecond. So I'm just pointing this out. I would like to understand how this works.
Yeah, it would take me at least another 5 minutes, but I mean, you actually can make things like multi-management much easier, because if you are thinking about like a request-response type of interaction, you don't need to signal location. You basically can resume your session seamlessly, but just continuing to request on your new point of attachment. Of course, you also need to take care of the other direction, but that's doable. Yeah. Moving on.
Okay. So we go to
Thanks.
now. Next is Marcos presents. Marco, what was your presentation? Was PDF file, right? Okay, we'll find. What was the name? Marco.
Next is a very short presentation about challenges in next generation core
Can you connect to it?
development.
Will connect to. Docs computer.
So one of the major challenges is for next generation core to tackle a huge amount of devices and a huge diversity of devices. So devices have different communication patterns, mobility patterns. Some are power constrained, some are not. So this brief presentation is about how can we be smart in providing connectivity and maintaining connectivity for these devices. Joint effort means there is a European project. It's an industry collaboration project running. I have one slide on that, which is a group of partners from industry. First slide. No, I will come to that later. It's just the intro. I keep the 5 minutes somewhere. To tackle these challenges. So various use cases are being discussed for 5G, including IoT, machine type devices, sensor devices, mobile internet with high-speed internet access, smart devices, mobile content sources, and the mission critical. It's not the latest one, right? Which is in. Anyway, it's fine. Let's proceed with this one. And then mission critical devices which have even more constraint on bandwidth and reliable communication. So for machine type devices, there are a massive number of these devices. Some are stationary, some are mobile. Even if you have a stationary device, you may need something what is called today paging, not to locate the device, but to wake it up, right? In case it needs to be reachable. Some sensors, they wake up periodically and send a measurement sample to the network, so you don't need reachability. So the question is how to tackle all these different challenges in devices about heterogeneity, not only heterogeneity in devices, but also heterogeneity in different access networks. How to manage these resources and how to be cost efficient. Some of the enabling technologies being discussed is network slicing, which is mainly a group of network functions being isolated from other ones. So that eases network management. Separation of controlled data plane, separation of locators from identifiers. There is a lot of work also going on in the IETF, which may be relevant here. So how can we be smart and tailor a service being provided to a particular device? Next one. So here, so how can we be smart? We identify there are various devices with diverse communication patterns, mobility patterns, energy constraints, and also capabilities. So there is a lot of context information being available. What we have today is subscription context. We can find out more about the device capabilities, about profile information, maybe even on-demand preferences being sent from the device or the subscriber to the network can be taken into account. Statistics can be taken here. So we have a lot of information available of a particular device about the service level agreement and the expected service behind. So how can we be smart? So we have two categories identified. So one is selection, so mainly a choice from available resources. If we have different isolated control plane slices and data plane slices, we can select from this set. It may be a large set, a small set. And then how to peer control and data plane slices. So we may have a one-to-one relationship between one control and one data plane slice, or a one-to-n. So one control plane slice can drive multiple data plane slices. After selection of the slice, we need to pick the particular network functions which we need. That can be a control plane anchor on the data plane. It can be data plane anchors, which basically determine the path of the data traffic. So after that selection, we can perform configuration. So configuration means the setup and use of only the required resources, not a default set of states and resources, but tailor it to the device's needs. So what all the devices need is connectivity. So that's a base and fundamental requirement for all the devices. Otherwise, they wouldn't attach. Everything else, which is today default, which is location tracking, reachability, handover optimization, IP address continuity, it can be made as a service. So we add this on top of the connectivity, and in that sense, create states on the control plane and data plane only if required. Next one. So as I said, there is currently industry collaboration project running in Europe, which is called config control of 5G networks. So the main objective here is convergence and being access agnostic. So I have a common control plane in the core that drives multiple access networks. Functional modularity. So the intention here is to not stick to 4G, but to be a little bit more disruptive in addressing a new or defining a new network functional architecture and have this in a modular way, which allows you to pre-design control plane slices as there is need. So we identified different functional elements for connectivity management, mobility management, flow management, security, and access transition. Context awareness is a very fundamental part to enable smart selection and smart configuration of control and data plane. So this activity runs actually as a regular European project. We have work packages about use cases, requirements, functional architecture, and then about the solutions. So one of the key aspects is to specify solutions for smart connectivity. Plan is to evaluate and prototype this. Dissemination and standards impact is very fundamental, and 3GPP, also ONF, but also mainly IETF, we see as these standardization tracks where relevant work is being done.
Thank you.
All right, that's it.
Thanks, Marco. Any questions quickly? One question we can take. Any questions for Marco? Anyway, you can ask after the presentation. So Don, Chia, I have yours. Finally, I'm sorry, I had lost network connectivity. That was the reason. We were getting problems. Okay.
Okay, hello everyone, this is Jie Dong. And I'm going to give a high-level analysis of the gaps in IP transport for the 5G requirements. Okay, next slide. Okay, we know that 5G brings a lot of new requirements on the transport network. Basically, the most important ones are listed here, like low latency, large bandwidth, network slicing, and programmability. So we need to identify whether the IP transport network today has some gaps in these areas. Okay, next one. So for the low latency, we know in 5G services, some of them will require ultra low latency, like for the front haul CPI transportation, it will require 100 microsecond delay in the transport. And for the mission critical IoT services, typically the delay can be afforded is 1 to 10 milliseconds. And which means if we want to use IP transport to support these services, it need to provide bounded latency. Currently in IETF, the data networking group is working on this area, and it may also need to coordinate with other organizations and other mechanisms like the work in IEEE 802.1 and the 6TiSH. Okay, for the large bandwidth, we know that front haul CPI may need several hundred gigabits for each site. And for another popular service in 5G, the virtual reality, it may require large bandwidth for each user. So this will all have a requirement on the transport about the huge bandwidth. For IP network, to meet this bandwidth requirement, there may be something to consider. The first thing is how to bounding the ports to provide a larger bandwidth than which can be supported for one single port. And another thing is provide guaranteed bandwidth for this kind of services. Because for the front haul, for virtual reality, they may require a very stringent bandwidth, and you cannot mix them with low priority services. But the final previous. Another thing is the benefits of using IP transport is the statistic multiplexing. So we still want to use a statistic multiplexing when it is possible in these scenarios. So this is a kind of challenging for the IP transport. This one, the network slicing, is a very popular and hot topic recently, which means the 5G will provide diversified services in the same single infrastructure. So for the transport, it means each slice needs to provide a different transportation service, which including the different topology requirement, and then maybe different slice will require different forwarding paradigms and different QoS parameters like loss, delay, jitter, and bandwidth. Also for different services, they have different requirements on the reliability. So we have a question on this part is, can the existing VPN technologies meet the network slicing requirements in the transport? The analysis, in my own opinion, I think this part we need to have more analysis and more investigation, especially for the any topology connectivity and for the service resource management. Maybe there's still some gap in the existing VPN technologies. Okay, for the programmability, it's mentioned a lot in the white papers that 5G will require the SDN for the better programmability of the network. But still, we have the distributed network today, and it is not quite likely that the IP transport network will become totally centralized controlled. So what we need is to find a balance between the centralized control and the distributed functions to meet to provide the required network programmability and meet the requirement in the flexibility and scalability, which means we need to consider both the northbound interface, southbound interface, as well as the signaling control plane between the east and the west. So for the next step, I think we need to work further on identifying the missing gaps in this area, and also analyze and discuss potential mechanism to fill these gaps.
Okay, thank you. One question, Eric?
Eric, not Mark. Just a clarifying question. You said different forwarding paradigms on the slicing side. What does that actually mean?
Yeah, what I mean is some network slice may require layer 3 IP forwarding, some may require layer 2 forwarding, or some may require even non-IP forwarding paradigms, like what is called ICN or something.
What is ICN?
Yeah. Information-centric network.
Okay.
So there's a lot of flexibility. You need to meet all these requirements in the same network.
Okay, thank you. So, we prepared with Dirk a couple of slides as we want to show it as an overview. So basically what happened in on the mailing list, we have been discussing many things. And one issue that was raised was we need to simplify layering. Someone, I think, raised it on the mailing list. So how can we simplify layering? Because currently, especially in wireless networks, we have a lot of layers that are being used, and they cause long packets, MAC and IP headers and so on. So here, what is being used today, and what is being used today, for example, the LTE side, protocol layer. And then in the 5G area, what we can have. So basically, the FIA means future internet architecture. And so simplify this to only 3 layers on the side, and then above that the transport layer. So on the user side, and then the servers, then the network has only 3 layers in the base stations and the routers. And and radio access specific layers are only limited to the lower 2 layers. Now, this is another proposal, more sophisticated, again, based on this narrow waist idea, narrow waist IP, but you can question, is it going to be, the end result is going to be so narrow waist? So all these things we need to add in order to satisfy the 5G requirements to the IP layer, and then link layer, other layers do not change. So I'm going to talk about a little bit shortly. These are from the so-called Mobility First project that was conducted in some universities in America, and they completed, I think, end of last year. So they came up with several interesting ideas, and some of them they tried to work out some detail. But it could be that for us to look into these things, and then maybe we can get ideas for some future work in this group, if people are interested in. Because basically, our attention, I think, should be, since next generation IP is this IP layer. And so what is going to look like IP layer in the future in the 5G networks. So then these types of things we see in the IP layer, in the data plane, and then control plane. These are the things we see. So now next, I would like, and then again, this ILMP, Identifier Locator Network Protocol, has been discussed very shortly, and also LISP was discussed on the list. And Cameron Bynes, I don't know if any of you know him, he's from T-Mobile, and an IETF guy. He contacted us offline, and he suggested this ILMP is a good direction to go. So we made up a few slides about ILMP to just introduce. And then I noticed that he had a draft. He's there. I think he is presenting Interia afternoon about ILMP. So I asked him to come to this session just because we are talking about ILMP. So ILMP is, I think, this Identifier Locator Protocol. This project was finished in 2012, 4 years ago, in the routing area, the IR research group in RIETF. What do you call it? RIETF? Something. Sorry. Yeah. So, but it was all published in a series of RFCs, like 8, 9 RFCs. And there's also more work going on in the research. Dirk contacted them. Maybe we can talk about it later, very shortly. Now, basically, the idea is very simple. We have an identifier and a locator separate, and then Lisp, similar to Lisp idea. Then I think they started this first, and then Lisp continued in some other way. So the approach here is different from Lisp in the sense that the ILMP does not modify the routing system, and it's completely compatible with IP, with IPv4 and IPv6. IPv4 version was defined, IPv6 version was defined, and some modifications here and there. I'll explain what is modified. host is modified, of course. Then ICMP and ARP have been modified, and DNS is modified. So it's very limited modification to the current IP layer. So, so we can see that IP layer modification required here. No modification to IP multicast and no modification to the routing system. So basically, the transport layer keeps identifier, local identifier and remote identifier in the state. So this way, when your address or locator changes, so the session doesn't break because it's based on your identifier. An identifier is very simple. Is EUI64 formatted some node name. Okay, it's called node ID, NID, node identifier. And then locator is the IP subnetwork that the node is, the interface is in. So, or like a network prefix, network routing prefix associated with that subnetwork. So, okay, now I don't want to talk very long about these things, but it's, yeah.
So one comment. So we're working,
right? Yeah.
Tom Herbert.
I forgot your name, yeah, Tom Herbert, yeah.
Yeah, thank you.
Okay, Tom.
So we're working on something very similar to ILNP, identifier locator addressing. The difference is, so it's basically a 64-bit locator, 64-bit identifier like ILNP. Unlike ILNP, it does not require, yeah, the same. Doesn't require changes to TCP, which we like. And we actually have implemented this for data center mobility. Have not thought too much about the more general context. I can certainly look at it, but it's kind of like ILNP. Best way to think of it, ILNP, but a real manifestation of it. So we actually have implementation and starting deployment of it.
Thank you. I think your experience is very valuable, and we need to contribute you more. Maybe if you continue on this in this direction, this list, I think you will be.
So, and one thing, we'll be presenting ILA Friday at Routing Working Group, RTWG.
Okay. Now, DNS changes. Of course, you need to define all these things and then they define these RRs, and then they need to be supported by the DNS servers that you are contacting. Basically, you give the identifier, you get the locator. So that type of, normally it's FQDN, but then with this they change the identifier NID, then get the locator for the node. You're looking the address of the node. Then so the host sending packets to the correspondent node. CN is correspondent node. So what does it? How does it work? I think it's pretty simple. Now, so basically, what their main interest was the host mobility, multi-homing support, and so on. So I didn't include multi-homing discussion here. The host mobility is basically two things. Every time the host moves, we need to do locator update message, ICMP v4 or v6 locator update message. The host sends LU messages to all the corresponding nodes. So then and then there's a dynamic DNS update message. So I think this is something that they wanted to avoid in Lisp. So they decided to change the router's routing system, and that makes it more difficult to deploy. So why are we interested in this? Because first of all, it addresses only mobility of issue of 5G. ILMP compared with Lisp is easier to deploy. And Cameron Bynes suggested to work on 3GPP specific issues for 5G mobility using ILMP. So that's the reason we got into this, and then I prepared these slides. So it looks like if you want to apply this to 3GPP, maybe you need some changes in the current ILMP protocol. So that is something we can look into if the group is interested. And Dirk can say something. He talked to this.
Well, not really. Well, no. Yeah, but I did not talk in detail to him. So I hope that he will contribute to the list further on, and we can then discuss there. So it's not much more that I know.
One thing they say, I think there's no socket interface doesn't change with this. So I think that's an important result that they got. Okay, next is this mobility first slides. I think they're very flashy. I don't want to. If we can cut any time if you like. So this is explaining what I showed before, what those things are, okay, like GNRS, global name resolution service, and then name, what was it, NCS. So similar ideas, but they're defining more globally unique flat identifier, GUID, and then global name resolution service, which should be very quick to resolve these some nice ideas. Anyway, we'll post these, and they're in the internet actually. It's not, I didn't make these slides, so they're all public domain documents. So, so basically, the idea is to keep these extensions in the some name address header in the PDU, but the fast path is always the current IPv4 or IPv6, doesn't change, won't change. They try to not to change. Similar things in ILMP ID. ILMP they put into the optional option headers and IPv6 extension headers and so on. So that's the idea, to not to disturb the current routing and forwarding. Okay, now, so we have the CNRS slides. Oh, the other one is the storage aware. I think on this one, this cache and forward processing in the router, there is this segment routing. I think it's being done in IETF currently. Segment routing group is working on this. So basically, routers have storage, and then you can do hop by hop transfer of things, hop by hop transport. For example, the whole movie can be transported this way in the routing system, and this is currently going on in IETF segment routing group. So some of these things are being implemented, and context-aware delivery. This is also a very interesting idea. Basically, you want to address things with a context, like all taxis in Buenos Aires, or all taxis in around Hilton, things like that. So, so with these, for context could be like geographic coordinates and first responders. So then convert this to some global name resolution service, to some GUID, and then some multicast, and convert into some transport mechanism, and then this can be processed in the network. I think these are great ideas. They need to be worked out for different IP layer type of changes. Okay, so this mobility first and what we can do. This is many issues in 5G, not just mobility. And many new directions like TNRS, NCS, network name certification services, and storage aware routing, as I said, is already being done, I guess, in the in IETF somewhere. Then content and context-aware delivery. So these are the things we can look into more on the list, discuss, and then hopefully in the coming months and maybe next year sometime, we can find a good subject and go for a BOF. This is one of our aims, of course. Yes, I'm finished.
So, Dirk Kutscher, so I'm not sure how to articulate this best, but I don't think it's a very good use of our time when we kind of jump into very specific potential solutions from, say, a bunch of research projects without really having discussed like design goals, architecture, let alone having some common understanding about that. So I'm not sure how helpful this really is at this point. So don't want to be impolite, but I'm not sure.
Yes, sure.
Marco Liebscher, I have a clarifying question. So at the very beginning of your presentation, you showed two architecture proposals, and in both of them you have something like, one you said it's a next generation IP, in the other one there was something like IP plus mentioned in the architecture. So can you just clarify what's that? Is it still IP, or is it something that will replace IP? Here you said something like next generation IP, and in the previous one there is IP plus mentioned, and I'm just wondering what's that?
Here?
Yes.
IP plus?
Here, IP plus.
Yes, this means changes in the IP layer. Plus is for the future Internet architecture, FIA. This is the term they use in the literature, I mean, the university project. Yeah.
But we still will have IP addresses, right?
If you look at the ILMP, for example, all the changes that I mentioned, for example, DNS changes, ICMP extensions, those are this IP plus. Like, you know, IP layer, they belong to IP layer, officially, layer 3, right? So,
Carlos Bernardo.
Those are the minimum, but the other project introduces more changes, bigger changes.
Carlos Bernardo, UC3M. Carlos Bernardo, UC3M. So I have a clarifying question of the goal of the meeting itself. My understanding was that the goal of this effort was to identify some issues that 5G may bring related to IETF, and try to identify those issues, and then to identify in which working groups those issues may be tackled. Not thinking of both, but first thinking of identifying the gaps, whether there is room already in IETF, and then start working on those. So that was my understanding, and if that's correct, so how we can progress to get there, because I think it's not an easy exercise, but I think that will be the useful part.
Yeah, I think, okay, I agree. So the issue is to scope better. So like we have, you know, many proposals. I think Dirk talked about congestion control, which is more like transport layer. So here we wanted to do more IP layer stuff. So, but still we can consider congestion control if people are interested. So that's I mean, these slides have that aim that we can scope around the IP layer and still find good things to do.
Eric Nygren. One of the things that jumped out at me a lot of. Oh, Eric Nygren. Eric Nygren.
Okay.
One of the things that jumped out is a lot of these slides seem to be on the let's just throw away the architecture of the internet and come up with something whole new from scratch. It seems like there's a lot of that where I wonder why there's not more of a focus on okay, let's forget about IPv4. We move on from that. Let's not try to deal with any compatibility with that other than as a service over IPv6. But for everything going forwards, just figure out what are really the problems we need to solve to be able to terminate server IP connections to user equipment deeper in the network rather than having to go through centralized IP gateways. Like, it seems like if we could do that and just figure out what are some of the changes to the existing protocols that we would need to do that, there's less of a throw everything away and more of and then it becomes okay, what are some of the things we need to do to focus on the mobility stuff, or which are the bits of the congestion control that we need to go change in that within the existing framework rather than starting from scratch with a whole new framework.
So you're sorry, can you say that you're suggesting that we should more be revolutionary and
I think
from scratch?
I think it seems like being more evolutionary may.
Yeah, these are more revolutionary.
Most of the stuff here looks completely and totally revolutionary in throw everything away, start from scratch. Like, if rather than the evolutionary, which is okay, today we have effectively IPv4 and IPv6. A lot of the mobile networks are now really deploying IPv6 to the point where we're on a path to being able to not really worry about the IPv4 other than for legacy stuff. But even that IPv6 connectivity is terminated onto the internet, something that in a place that's far away from where the handset is and actually gets tunneled over some other some other protocols before it gets there, how do we move that? Like if we focus more on how do we move that closer to the edge, which I think is some of what Cameron was trying to propose, and what you were talking, I think you might have been talking about, like trying to keep TCP the same, trying to actually just keep IP the same, but focus more on what changes do we need for congestion control, what changes we need on the routing side, what things can we do to make multi-homing work better, what are ways we can hook better into CDNs or DNS for being able to handle some of the load balancing mapping situations better, then it's something that becomes a more practical problem to solve with existing real world situations.
I'm really having a problem understanding your proposal, because I thought that this is what we are doing here. All these changes, especially ILMP, is basically very evolutionary approach. So small changes.
And I think some of it is but still, even in ILMP, you're looking, when you start getting into the oh well, let's just replace TCP with something slightly different and require kernel level changes everywhere. You start getting into the realm of things that take that are very hard to actually practically roll out. Like this is from the side of a kind of from the content delivery operator side, just seeing how hard it's been to get to where we are with IPv6 today, that trying to change too much of that stuff in the narrow hourglass, the less you change, the easier it is to roll out.
Okay, thanks a lot. Yeah, I understand now. Next.
I have to do this. Hi, I'm Natasha Rooney. So I was looking at this slide, and part of the things that we were trying to do with the output of the Manu BOF and or the Manu workshop and the Accord BOF that happens later this week is to promote more people in telco space to create drafts based on some of these problems. So the presentation's fantastic, but if you write this up as some sort of informational document in an IETF format, that would be beneficial to a lot of people. My personal viewpoint on the congestion.
Yeah, that's a good point. We need to write the raps. Yes.
Yeah, I want to do a lot more of that myself, actually. So it's a reminder to myself too. The other thing is that with regards to the congestion control stuff, I still feel that exists perhaps in existing groups or new groups that might come out, or new work that might come out of Accord rather than in here. This is more 5G and IP. So I think it probably needs to be more focused towards the IP stuff. In the presentations, I only saw one real clear reference to a piece of work, which was the ILMP piece of work. The rest seems to be suggested, sort of ideas of things that we could look at, which seems to call for something more than, jumping straight into doing work, but gathering more people around in a bar off or something like that. I'm not sold myself. My hopes for this meeting that it would be more of the kind of requirements of stuff that's come through on the internet that we could perhaps bring to the 5G space. But that hasn't really coalesced, I guess. But yeah, that's my comment.
Yeah, thank you. I think I suggested you put these things into a mailing list and maybe try to get answers better discussion later. I'll appreciate that. Actually, for everybody who asked questions, if you can start some discussion threads on the list, that's going to help us a lot. Yeah. Okay.
So Eric Nordmark again. So I think that at least I feel that there's some high-level problems that have been described that people want to solve in the 5G space. But I feel like it would be useful to sort of drill down into those a bit more and understand those problems a bit better. And there might be some of them we understand better than others, but sort of what motivates these things that people are proposing? Because then we can see, do we have IETF technology that already applies or work that's underway, etc. Because right now I feel like I don't have enough information to decide what's already there, right? What is it? Just an educational problem that, oh, we have this piece over here, you can just go use it. Right?
Thank you.
Tom Herbert again. So I agree mostly with evolution is better than revolution, but there is one thing that I think needs to be addressed, and was kind of alluded to since we're encrypting packets, we're losing information. And this is specifically for forwarding, and I think that's kind of, I don't know if it's an architectural flaw or what, but speaking from the end host, we never really think of forwarding as using definitely TCP payload or TCP headers even. And it would be nice if somehow this work became more protocol agnostic. So if we actually needed something in the forwarding path that is related to, say, the transport layer, put that into L3 information somehow. So in the end of the day, if forwarding would just be layer 3 and we use all that information, that would be good. And I actually think IPv6 has some nice hooks to be able to do something like this anyway.
Okay, thank you. Next, probably last, because I think we have to.
This is Putnam. So there is a couple of things that people have been saying, and I tend to agree with Eric, is that I think there is a number of requirements, and some of those proposals of those architectures need to be assessed and refined. I don't think there is a one solution that fits all the requirements of 5G in any of them. So I really encourage that we actually look at the requirements and, like you just said for me, borrow pieces that we know work, maybe, but I don't think that we have a ready solution. We can just say, jump on that one and it's working right now.
Okay, thank you. Actually, we had a lot of participants on the Meet Echo, but no question there. Okay, folks, thanks a lot for this good attendance, and let's continue in the next IETF in Berlin. And again, we'll make a call for presentations. People who want to present, make sure to prepare a good presentation. Yeah, also meaning it's quite a little tough. Yeah, hi, Michael. $90% off? Yes.